the purpose of today's lesson is to understand how to solve equations that have multiple fractions. Okay, we've already dealt with solving some equations that had one fraction or maybe two fractions in there. But now we're going to deal with when they have multiple fractions. Okay, so let's walk through the steps we're going to need. Step one is the same first step that will always be used, which is to use the distributive property to remove parentheses. Step two, determine the least common denominator of all the fractions, even if they are on opposite sides of the equal sign. And again, like most of this, when we walk through and some of the examples, it'll be a little bit clearer. Okay. Step three is to multiply every term by the LCD, or least common denominator, even if not a fraction. After this step, there should be no fractions left. Now, the last step, not really a step, but what we're just going to do is then solve the equation following the previously learned steps. So in other words, combining like terms, collecting the variables, unwinding addition, subtraction, unwinding multiplication, division. So solve the equation following the previously learned steps. So let's walk through 4 examples, and hopefully you'll have a much clearer idea of what's happening here. So now you'll see I have multiple fractions in all of these problems. So, and I just wanted to point out, obviously fractions can be converted into decimals. And if it's a fraction like a half or a quarter, that's easy. But if it's a fraction that has a denominator of a 3 or a 6 or a 9, those are going to give you repeating decimals. And so therefore, they will not be very accurate if you try to convert them into decimal form. So what's my LCD? It's 10. 5, 2, and 10 all divide equally into 10, and that's the smallest common denominator. I take the first term, which is 3x over 5. I multiply that by 10. Well, I'm going to just cross-cancel. That's the whole point. There should be cross-canceling throughout this whole problem. Don't forget to put the variables in. Now I replace what I originally had with 6x plus 15 equals 7x. I now have a very simple two-step equation. And I'm done. All my denominators disappeared, making this a much simpler problem. Okay, LCD here is 12. And again, do all of this math off to the side, because if you try to do it somewhere in where the equation is, it's going to become a big mess. Okay, so 3y over 4 times 12 becomes 9y. 7 over 12 times 12. 7.
The lights go on or off. Thank you.
and 2y. Again, I'm left with a very simple two-step equation. I subtract 9y because I want to collect the variables on one side and leave the 7 by itself. That's a negative 7y. So I divide each side by a negative 7 to get y is negative 1. Okay? Continuing with the next two. My LCD is 18. I get 6x. I get an x. And I get 21. Very simple. 6x plus x equals 21. And you can see how much easier this is an equation to solve. Last one. My LCD. Now this is 5, which is 5 over 1. So my denominators are 3, 3, and 1. So my LCD is 3. This looks a lot more complicated than it really is. The last thing is people forget to multiply that 5. Remember I said every term gets multiplied by the LCD, even if it's not a fraction. So now this becomes x plus 4 equals 5x minus 3 plus 15. Combine these like terms. I'll get rid of the x. Get rid of the 12. Divide by 4. And x is negative 2. Okay? So, again, the trick here, if I have multiple fractions in my equation, is to get rid of those denominators so as to make it a much simpler equation to solve.